Hello, my friends, family, countrymen. This is Dan Davis from the Fabricator magazine. I'm being joined today by my co-worker, senior editor Tim Heston. We're going to talk about the May 2022 edition of the Fabricator magazine. Should be hitting inboxes and mailboxes right about now if you haven't received it already. And we kind of chatted before we came on camera, and I think one of the interesting things that readers will find in this issue is an article addressing just how much laser power a fabricator might need in its laser cutting machine. Tim, this is something that if there's anything that's kind of caught our collective eye that is constantly kind of pitched to us from the machine tool guys is more power, more power, more power. And I think this kind of looks into some of the questions as to whether all shops need all that power. What did you kind of find out as you worked on that piece?
Well, yeah, it's kind of like the Tim Allen, let's rewire it, more power, and just, it's kind of the, but of the, it kind of resembles the industry of the 1990s when we had the CO2 power race, right. And then all the way up to 12 kilowatts back then. We had some but then of course, the fiber laser just kind of changed the game with that. But of course, it's not all about power. We have beam shaping technology and beam manipulation technology out there that giving clean cuts, and you can eliminate dross and eliminate secondary operations. As one reader told me, hey, it's about, laser cutting isn't complete until it shows up at the next major step, which is usually forming or assembly. So if it has to, get in queue behind a long line of deburring parts, it's that's still laser cutting, so to speak.
Right.
And so that's one aspect of it. But the one covered in the May issue, it really covers a really great presentation that Troy Wilson of Cincinnati Incorporated made at FabTech, and that about how much laser power you really need. And he really took a broad view of the whole situation and saying, all right, first you got to determine, he outlined 4 steps. Who are your customers? So, which basically your customer mix defines your business model. If you're a job shop, your customers are cross industries and you're make to order operation. If you're a contract manufacturer, you may be specified to certain industries or a narrow range of industries, or at least have blanket orders that are dedicated to certain value streams, and you have a different production model for that. Or you're an OEM, where the product, demands of the product and customer demand of the product drives everything in manufacturing. And so, Troy's point was, hey, if you're if an OEM is going to buy a 20 kilowatt laser to just push a bottleneck downstream and it's overtaking customer demand, then why do you need all that power? There's really no need. Whereas even the smallest job shops out there who are really progressive, they could benefit from this massive amounts of laser power if they have certain business models, specifically if they want to be the shop that responds. It's not about machine uptime, it's about machine response time. I can go in there and shut it down, switch over, process a hot order, get it to a customer within a few hours with the right margins, and you can make a healthy business. Yeah. But it just depends what kind of business you are. That was number one. Number two was, what are your resources? How much shop space do you have? How many shifts are available? What external resources do you have, like painting and plating? So if you've got outside services and that's again shoving product to a bottleneck process. So if most of your parts have to go to outside plating, well, maybe 20 kilowatts of laser cutting power isn't for you. Again, it depends on the operation, and it also depends on the capabilities, your order to ship chain of manufacturing steps. And the fourth and final one are the operating costs. And this goes into what are your energy costs? What do you pay for personnel and maintenance? You talked about a shop in San Jose that these days, these high-powered lasers are doing, wonders with ultra dry shop air and also nitrogen generation and also gas mixing. But also when it comes to nitrogen generation and ultra dry shop air, especially nitrogen generation, I should say, it does take a significant amount of power to run that. Yeah. And so that has to fit into your operating costs. Like, does this make sense for my operation?
Mhm.
So which costs, it entails the gas cost. So it was a nice broad FabTech presentation, which we summarized in the magazine this month. So,
Yeah. Hey, you brought up the CO2 kind of power race, and it just makes me wonder, can you compare and contrast that with what's happening today, or are fabricators more sophisticated in the sense that they'll ask the questions, when it seems like back then it was just the capability of just cutting that 1/4-inch plate, because that timed right in with the whole armament buildup for the vehicles overseas in the Afghan war.
Right, and
that's what I remember a whole lot from that era. What is your take on kind of comparing those two different time periods?
These days, I guess it's difference between brute force and actually just what the shop really needs. There is a differentiation, so that you can have, there are 40 kilowatt lasers out there, right?
Right.
But it's how cleanly does it cut, and what are the downstream operations, and as far as plate cutting, what are the competing processes? That's something else that Troy talked about, is that plasma cutting has come a long way too. So high definition plasma, you may have a cleaner, nicer edge than something that's on 1.5 inches. Then again, if you have the right beam shaping technology or beam manipulation technology, you've got some amazing looking edges, and you can really dial it in with the fiber as well. So there's all sorts of, and of course, there's always been those specialty shops with CO2 lasers. We covered, Brent Donner years ago, who just can do things with a CO2 laser I've never seen anybody else do.
Right.
At Donner Laser Cutting. But it's and we had a 4-part series with him a couple of years ago, and got reader calls going, how did he cut 1.5 inches with CO2? Well, he really dialed it in. So you're always going to have that market niche, but how big is that market niche, and how successful will you be? Because the majority of our world is quarter inch and under, 1/4 inch and less. So.
Yeah, it's funny you bring that up. In terms of somebody having the knowledge to get the most out of a piece of equipment that may not necessarily be the latest and greatest, but we kind of tie that in. We mentioned bending, and obviously that, if anything, the powerful fiber lasers have really put pressure on downstream processes. Bending is press brake area, exactly one of those. When you worked on that article for May, it was called "How Bending Virtually Changes Everything." What did you come across? And I guess what I'll ask you is, is this becoming the de facto standard for people bringing in new bending technology into their shops? Because to me, I get that sense, I see it more and more, that if anybody's doing programming on the floor, it's to accommodate an older press brake, or maybe even the operator who just was used to doing that.
Right. Well, this article was from Amada's software specialist, and John Paranzan, and he mentioned that the majority of new brakes sold today come with offline bending software and simulation. It's just kind of becoming the default. If it's not purchased outright, it eventually comes into play, because it just makes sense, especially in a high product mix world, and especially in an automated world where, when you need that offline bend simulation to get it 90% of the way for the robotic bender, you may need to tweak it here and there. But it's really just kind of becoming the default. But it's, and a big point behind the article was the different kind of career structures that this technology is creating. That people are learning the press brake a different way, and it's causing them to think more broadly and to think about more stage bending opportunities across the press brake bed, maybe design unitization, fewer piece parts, bending more complex pieces. But it really kind of changes the bending career. The worst case that can happen is, and we get a lot of readers comment on this, is that you don't want to dumb down the process. You don't want to have a bunch of button pushers at the press brake. You want to develop a press brake career to say, hey, this is how bending takes place. Look how the 3D bend software also shows how how airforming takes place. So it says, all right, this is the importance of, say, a minimum flange. It's like, say, this is how it grasps the edge of the die. And this is why you need this certain die radius so it catches, so it doesn't slip into the die. Or how do you want to avoid die marking? Well, no wonder it's marking because it's pressing there. There's all sorts of details that can be revealed from the software that's just revealed today in a different way than it was years ago when folks used to shadow a shop veteran and someone who would just march somebody through the calculations. So it's becoming a very different career, but it's just so much faster to program offline. You've taken that value. Taking that non-value added time. It's a value added time, but it's to an external process, so to speak, outside of the machine in lean manufacturing terms. So.
Gareth, you have a note for us?
Yeah, when we posted this article on LinkedIn a few days ago, we got a comment from a guy named Christian Grindel that said, if shops aren't investing in offline programming software in 2022, they're basically just lighting money on fire.
Yeah. Well, I mean, so the old thing I used to hear is, you want, I mean, it's kind of basic, but, if that RAM's not going up and down, they're not making money. That's the only way they're adding value to that part. So having somebody sit in front of that brake, spend their time trying to figure a program out, it kind of makes sense.
Right.
Yeah.
And it does, admittedly, it changes where the creativity happens, which is a shift. Right. I mean, I've visited shops where I've seen a supervisor and a press brake operator, or a press brake lead and press brake operator kind of work together through a print and just kind of do and then finally figure it out as far as how to do the bend sequence and do a high five and wow, what a great day this has been.
Right.
Unfortunately, the RAM's not moving up and down, and that's not making the shop money. Now this happens in software, and it potentially will happen in software in the years to come, even when the edge cases where you're pushing the limits of the press brake, it's only going to expand. It's just a different career, and it's a different reality on the shop. And the danger is that you don't want to have disengagement on the floor and people don't care and they just push buttons and just move on to the next. You want them cross-trained and engaged in the broad way.
Yeah, I think a lot of shops, inevitably have an older press brake. They probably still use it for like special jobs in which they've invested in tooling. They want to keep it on there. But that gives new people an opportunity maybe to learn some of these basics, kind of have that back to the future moment where they're learning, they're learning as maybe their mentor might have learned. Are they going to absorb as much as quickly because it's not as hands-on? Probably not. But, just a plug for FMA, Steve Benson leads a couple times a year, I think, a press brake certificate course. So, there's opportunities for people who want to have more knowledge, and for companies that want to maybe kind of develop a press brake guru for their own organization. That's to me, that's all. It's always good to have people who know stuff. It's the only way I can get through life.
Well, that kind of dovetails off. I mean, this is May. This is June. This is coming up later, but that's when we're having our Fab 40, which is a list of top fab shops in the U.S. But one of the shops participating this year, they have air bending, a new press brakes for air bending, but they've got these products that have been legacy products that have tight radii on them, that the tooling they have in-house, they have to do bottoming on it. They have to do bottoming on older press brakes that require manual setup. They have arranged a cell flow to deal with that and to allow time for brake operators to set up that brake while air forming other parts so that parts flow through the cell. And we talk about that in the article. But the knowledge is still required if you want to produce parts that customers desire, that they have to move heaven and earth to actually change a design.
Yeah. No.
So it's it'd be great to make this radius the same as the material thickness and actually make it good for air forming. But no, it was designed for bottoming, and we ain't changing.
But I think that goes back to your point about creativity. The focus in this sense is on the flow. And how do you make that work given the customer specifications that are required for that job? So, I think that totally is probably more reflective of the metal fabricating world than new shops with totally online press brake programming and utilizing virtual bending. In all likelihood, shops probably have a mix, and they have to make it work. Yeah.
Well, I think that kind of leads to our cover story, which was so many shops over the years, they've gotten rid of the punch press to the point where a lot of folks, a lot of community colleges, they don't teach the punch press. They think, oh no, there's no, some community colleges I've spoken with say, yeah, no, it's laser's the future. And I tell them, well, you can't form on a laser,
Right.
and the punch press is still valuable. But if you don't do a lot of forming on the punch press, okay,
Yeah.
why don't we replace everything with the laser? But then we still have those forming tools. So you worked on that story with just kind of the special press brake tools.
Yeah,
that
the
would
folks
actually,
folks over at Wilson have that. It's basically tooling that accommodates a punch tool, and people are able to kind of utilize that for exactly as you described. Those high, obviously, if it's a high volume, low mix place, they're probably going to have that machine. But for those that don't, they can utilize this maybe in a cell type format or a hot job that needs to get done. It's that's always been my favorite part of covering this job is the punching. I love watching that stuff. I love the sounds of it. To me, it represents everything that fabricators in human form are supposed to be able to do in terms of not only cut it but form it, and then maybe actually create almost 3D shapes. Not as greatly as you can do on a press brake, but all there in one machine. And people will make that point as lasers have gotten more powerful, the whole sorting aspect of it. Well, punches kind of addressed that several years ago just by dropping through part chutes and things like that. So it's always struck me as being kind of a tool that the very first lasers were basically punching machines with a laser attached to it. So
they were combo machines.
So in the material moved, the laser would stay still. So in a way, what is old is kind of new again. In this sense, it's taking the ability of those punch presses and kind of bringing it over to a brake, which once again, if there's anything that's been a part of metal fabricating since the early days, it's been brakes. So I think you really hit on it. The theme of today, if you will. The fifth caller gets a T-shirt, but it's all about creativity and how these processes go, and avoiding the working process in the aisles. And to me, that type of forming in the press brake is another alternative. And in a way, I think our publication, if we had a formal mission, is to just make people aware of this stuff. And sometimes it's the high-powered lasers, the cutting edge, and other times it's a tool that may not be as cutting edge, but really has a place that can make an impact somewhere. So it's always kind of fun to talk about the new stuff, but also find out how people might be putting it into action, or thoughts of how it might be put into action. That's one of the interesting things I enjoy about this job.
That's right.
Yeah.
Well, and you mentioned, because and again, right now I'm in the midst of putting together the Fab 40, which will be released soon, and just talking to all these successful shops and their approach to technology, specifically automation, where you have the full gamut of automation technology, where either some shops they take a different approach where they have manual denesting, and even laser operators denest. And have job sharing, because that teaches them, what good cutting looks like, and kind of job sharing is, and they're even doing the slack cleaning, and they realize that some automation requires some level of human intervention. So if I'm going to buy this automation, I need to reduce the amount of human intervention, or otherwise I'm just putting it somewhere else. So if you buy a robotic brake, well, if that requires a ridiculous amount of time programming it, what's the value of that? Why don't I just put it on the floor and have a manual operator bring it through?
Right.
And this is kind of the same thing on this in this month's, in May's issue about pipe welding. We have a autonomous pipe welding robot feature. And it kind of dovetails off the autonomous robot welding feature we had a few months ago, where the robot literally just does not need any manual intervention, and the programming is minimal, if nothing. And so it literally can augment a pipe welding operation or augment your existing welding operation. Somebody can just clamp it in, and it can sense the tacks and then welds from there. So it's that kind of operation automation really has a future in
Yeah. It's really exciting to hear about stuff like that, and I think it kind of feeds. I know people want to use the term modern metal fabricating, and then I think sometimes people will try to push that to the point where somebody will be convinced that they're working in some kind of giant clean room where there's no dust or anything like that. I think that does a disservice, but in terms of conversations centering around more robotics, more automation, without a doubt. I mean, that's occurring at almost every step of the fabricating process in a shop now. And I worked on a story that focused on deslagging activities at O'Neill Manufacturing Services in Greensboro, North Carolina. Could there be anything more unexciting in that sentence than deslagging? No one wants to do that. And as a matter of fact, the company had 32 people dedicated to tackling parts coming off a plasma table, removing that stuff. The company invests in 2 machines, one for deslagging, more for edge adjustments. They didn't call it rounding per se, as there's still somewhat of an edge, but just take the edge a little bit off, make it more suitable for handling. But the point being is they were able to take that manual deslagging activity, which was all, typically entry level, was for them, 32 people, and get it down between 3 or 6. And I remember the plant manager actually using the phrase, people actually enjoy working in the deslagging area now, because A, they're not doing it all the time, and B, the other part of that is they break up the day because they're running the machine as well. So in the bigger sense, you've had this opportunity to sell bright, interesting kids that may not have known about manufacturing, and you might be able to sell them on a possible career in metal fabricating. And then at the other end of the spectrum, people are just looking for a job. They're not going to be killed once they stumble upon a possible pathway when they get to a metal fabricating company. And I know that we've touched upon that in a couple past issues, particularly Jeff Sipes, making those entry-level jobs something that people want to show up and go to. I mean, right. It's not, people make the point, I used to sweep floors. I got news for you. I can sweep floors pretty well. It's a hell of a lot easier than deslagging all day using a manual grinder. So, from the very top of the investment opportunities with $1 million lasers all the way down to a piece of equipment that helps make it easier on the actual people doing the work on the shop floor. I think the magazine in May is a great testament to I think what people want others to believe about manufacturing. So
it all really boils down to moving the job forward. So no matter no matter how highfalutin your job title might be, the most important task is to move the job forward. Yeah. So whether it be a crane operator, which we could talk about in this issue, as far as proper ways to handle that in a safe manner, or pushing a cart to the next operation, deburring, whatever that you need to move that job forward is what the shop needs to make money. There used to be an old adage of if the machine isn't running, you're not making money. Well, if the machine's running, the shop is spending money because it's spending electricity, it's spending resources. The shop makes money when the jobs head out the door.
Right. Yeah.
and are paid for them too. So there's a collections issue too. So we're not, as Chris Keel has said in many FMA events, he also handles he's our FMA economist, and he also handles the talks with the Credit Managers Association. The credit managers say, it's not a sale until we receive the check. so there you go.
Yeah, some things never change. Yeah. We encourage people to pick up the May issue, take a peek at it, and before we go, if you have any questions, let Gareth know. In the meantime, I'll let you know that we have stamping in the EV world, that's stamping in the electrical vehicle world, coming up June 7th at the Inn at St. John in Plymouth, Michigan. It's a FMA conference Having recall the conversation that was had at the FMA annual meeting, whether you like it or not, electric vehicles are coming, and there's a lot of fabricating involved in terms of power stations, the actual vehicle themselves. I think they're anticipating a pretty good turnout for this event there. So if you have interest in that, feel free to look it up. www.fmamfg.org is where you can find more information. That'll be co-located with the Automotive Laser Application Workshop. I don't know if they still use that title. ALAWS, the acronym they kind of use in their marketing materials. That'll be occurring at the same place June 7th and 8th. And a lot of the things that are discussed there, you might be seeing in some of your laser cutting equipment down the road when you purchase that new technology. Gareth, we have a comment?
Yeah, our friend Steve Zerio commented.
Steve.
Just says, I think in regards to the automated deslagging process, he says it shows the importance of onboarding new team members quickly and efficiently.
Yeah. It's like I said, it's. I recently, actually talking for June, BTD out of Detroit Lakes, Michigan's the headquarters, or sorry, Minnesota's the headquarters. They, in their Lakeville facility, they just won FMA Safety Award. So the conversation was looking at metrics that kind of give you an idea how well you're doing with your safety efforts and having engaged employees. And their turnover for 2021 was like 36%. It had not been that high for a long time, almost going back 8 years, but it was all due to the robust job market. Having said that, they were pleased. They were able to fill all the positions they needed to keep up with growth opportunities, even though they had, in the words of the director of operations, they had to bring in twice as many people to accomplish that than maybe they might have had to do only 2 years previous. But having those things in place to help new hires, A, get accommodated quickly, B, keep themselves safe and their coworkers safe, and C, get productive as soon as possible, really goes a long way. And I think it really helps those companies in today's labor market. If I know it was always at the top of mind for fabricators going back, 5, 10, 15 years, it is unbelievably challenging for those folks. So, any more comments, Gareth?
There was just one comment from a few days ago about the automated deslagging process. It's a Facebook comment, so bear with me. It's from a guy who says he's been in the fabrication industry for about 30 years, and he says the parts cleaning related to injuries for parts cleaning on deslagging, he's just noticed that it's just been basically a reoccurrence of just poor technique and poor training, and basically the automated process is just highly needed because of the training on technique for deslagging just isn't emphasized enough, that he's noticed.
Yeah, and O'Neill Manufacturing Services would support that comment 100%. The other thing is, if somebody might actually know what they're doing, the more they get fatigued, the more they're likely not to do the right thing. So sometimes even people that have a knowledge of what they should be doing can find themselves in a position where they might end up hurting themselves just because they're tired. So thanks for that comment. I thank you for your time, Tim. Gareth, thank you. Thanks for everybody tuning in. Thanks to Brad Mills. Sorry, I forgot the S. Keep the S on for savings. I'm Dan Davis, Editor-in-Chief of Fabricator. Thanks for joining us, and we'll see you in June. Take care.
Yeah.